Hello! Today we're going to be practicing some molarity math, just a little bit. This worksheet that I've posted on the website actually has the answers attached to it, so you should be able to check your work without the video. But if you're having trouble with the mechanics of solving these equations, I'm going to go ahead and do the first one just to give you an idea how to solve these types of problems. And the first one is actually just about as hard as any of the rest of them on there. So if you get the first one, you're probably good to go for the rest. So problem number 1 says how many grams of potassium carbonate are needed to make a 200 milliliters of a 2.5 molar solution. So I'm going to start writing down some things that I see. I see 200 milliliters, and I know that unit milliliters refers to a volume. So this must be, and it says of the solution, right? So it's 200 milliliters of solution. So I'll say that's a solution volume. And I also see 2.5 molar. And we learned yesterday that 2.5 molar is a concentration, or a molarity. And then I see that we're looking for how many grams. That's my unknown. Now I gotta find grams of potassium carbonate, which must be the solute, the thing that's dissolving into the solution. So let's set this up. I need my molarity equation. Fortunately, that's the easy part. Molarity is always moles per liter. Well, looking at my givens here, I do have 2.5 molar, so I can put that in. That's 2.5 molar on the left. Equals moles divided by liters. Now, if you look here, I have 200 milliliters. That's not liters yet, but we're going to make it liters. So keep that in the back of your mind. You always have to match your equation. And the equation here is moles on top, liters on bottom. So let's come down here, do a quick conversion. I have 200 milliliters. I need to know how many liters that is. Multiply, put milliliters on bottom, liters on top, and I know milli is 1,000. So 1,000 milliliters in 1 liter, and I should get 200 over 1,000, or 0.2 liters. Okay, so I got that. If I come back up here, my molarity equals moles per liter. I have 2.5 molar equal, liters are on bottom, so 0.2 liters. And I don't know what's on top, so that's my unknown. Moles is my unknown. I'm going to be solving for moles. Okay, so let's do that. 2.5 equal moles over 0.2. I want to get moles by themselves, so let me get rid of the 0.2. I'm going to multiply the 0.2 on both sides. Okay, that'll cancel the 0.2 over here. I'll get 0.2 times 2.5, which should be 0.5 equals the moles. So I have half a mole. Now I'm going to check my question just to make sure. Oh, my question says how many grams, but I got moles of potassium carbonate. So I need to change moles into grams. Good thing we did all that stoic, right? So we know how to do that. So 0.5 is my number of moles. I have 0.5 moles of potassium carbonate. So now we also have to remember how to write our formulas. So let's remember potassium carbonate. Potassium is K, right? And carbonate is a CO3. Now potassium was a +1 ion and carbonate was a -2. So if I put those together, looks like I'm going to need 2 of these guys to balance out 1 of these guys. 2 + 1s to balance out a -2. So I will get K2CO3. Okay? Half a mole of it, to be precise. So let's put that over here. Got half a mole of K2CO3. And I want to change that into grams. So when I multiply, I'm going to put moles on bottom, grams on top. And if I see moles to grams, I always look at the periodic table. I know there's 1 mole on the periodic table, and then I have to look up for potassium. Well, potassiums are worth 39 each, carbon is worth 12 each, oxygen is worth 16 each, and if I add that all up, I should get 138 grams. Alright, so half a mole times 138 over 1, or half of 138. Oh gosh, what is that? 69? I think that's 69 grams of potassium carbonate. Grams of K2CO3. Let's make sure that answers my question. How many grams of potassium carbonate are needed to make 200 milliliters of 2.5 molar? Yep, I wanted how many grams of potassium carbonate, and I got 69 grams of potassium carbonate. So stepwise, just to recall here, I went through and found all the numbers that they gave me. I identified what the numbers were, what part of the equation they were. I identified my unknown here, and I plugged all that stuff in to my equation, my molarity equals moles over liters. Then I used algebra to solve. In this case, the only thing I could solve for was moles, but they wanted grams, so at the very end, I did a gram conversion to change moles into grams. And in order to do that gram conversion, I had to be able to note to make a formula. And the clue for that formula was that I was talking about this chemical, potassium carbonate. A lot of stuff. Okay, give this worksheet a try. We are definitely going to use the math from this worksheet in the lab this Thursday.